We would be glad if these help in getting your desired skills improved. Do provide your feedback, questions or any suggestions in the comments section. We would answer them as soon as possible. In this series of tutorials, we will focus on complete AutoCAD. Step by step. We will look into 2D drafting, isometric, and 3D concepts of AutoCAD.
This will be helpful for civil, mechanical, electrical, architectural, interior designers and others related to the field of drafting and designing. The first question that comes in mind is, what is AutoCAD? Well, AutoCAD is a commercial computer-aided design and drafting of software applications developed and marketed by Autodesk. AutoCAD was first released in December 1982 as a desktop app running on microcomputers with internal graphics controllers. Let's begin with our tutorials. This is the interface we get once we open AutoCAD. And here the name and version of the software is mentioned. Below this is the toolbar called Ribbon. We can start a new drawing from this option. We need to select this template if we wish to work in feet and inches. And if we are planning to work in metric, then we need to select this template. Once we click it, we enter the drawing page of AutoCAD. This section is called the command bar, where command input is given. The first step to be kept in mind is to set the required unit you want to work with. The command for setting up the units is the UN. For this, you need to press enter in order to get the command accepted by the software. This is the Units tab. Select decimal if you want to work in mm, cm or any other single unit system. Select architectural or engineering if you want to work in feet and inches. Under type, you can select the desired unit system. Under precision, select till how many decimal points you want the value to be considered. Under angle, select decimal degrees, as most of the angles will be in degrees. Under the insertion scale, select the unit you want to work with. Select precision for angles and click OK. Now, let's start with the commands. Basically, there are three segments in which the commands are classified. They are drawing tools, modification tools, and detailing tools. So, this was the introduction to AutoCAD. I hope you liked the video. In the next video, we will start with our drawing tools. Kindly subscribe to our channel for latest updated AutoCAD tutorial videos.
Hi. Welcome to our channel Cadd Excellence Centre. We at Cadd Excellence make tutorial videos of software easily available for all needing them for skill improvement or on job purposes. If you like our tutorials, kindly support us by watching the full videos. Hi. Welcome to our channel Cadd Excellence Centre. We at Cadd Excellence make tutorial videos of software easily available for all needing them for skill improvement or on job purposes. Let's begin with today's tutorial. Today we will focus on drawing tools used in AutoCAD. Drawing tools are available on the top left corner. The different drawing tools used are line, polyline, circle, arc, rectangle, ellipse and many more other tools which we will discuss in near future. There are various types of lines used in AutoCAD. The first thing is line. And the command for line is L. We need to press enter after every command in order to get it accepted by the software. So, let's start with the first command in today's tutorial. That is a line. For a line command to start we need to type L and then we need to press enter. The command is now activated and we need to specify the first point of the line from where it will start. Then we need to specify the second point. The second point can be specified by a click or by entering any required value. After clicking the second point or providing any required value, we need to press the escape key in order to exit the command. Now, if we need to create only by using numeric values, we need to start the same and just move the cursor in the direction we want the line to go and provide the desired value. I am using 200 as input. Now, if we need to create a drawing using only straight lines, We need to turn the ortho mode on. This can be done by pressing F8. We get the indication in the command line. So, in order to force the lines to move only in the horizontal and vertical direction, we need to make sure that the ortho mode is on. The line will only move in the horizontal and vertical direction when the mode is on, and it can freely move in any direction when turned off. Let's make a square of sides 200. To do this, enter into the line command and provide the horizontal direction, provide the value 200 and press enter. Then downwards 200. Left side 200 and upwards 200. In order to exit the command, press escape key. By any means, if we want to create a triangle without turning off the ortho mode, just take the cursor to a destination point where we want the line to go, and it will forcefully bend at that angle. So, these were the different ways by which we can create lines in Autocad. I hope this topic is clear to all, and in case you are facing any doubt, kindly drop any questions or doubts in the comments section. The next topic will be polyline, M-line, and X-lines. Kindly subscribe to our channel in order to receive the latest updated videos, and do press the bell icon to receive all notifications. If you like our tutorials, kindly support us by watching the full videos. We would be glad if these help in getting your desired skills improved. Do provide your feedback, questions or any suggestions in the comments section. We would answer them at the earliest. Kindly support us by watching the full videos. Welcome to today's tutorial. Today we will cover two more types of lines used in Autocad. They are polyline and multi-line. Polyline is a type of line slightly different from the simple line which we covered in the last tutorial. The command for polyline is PL or P-line. As usual, we need to press enter after providing the command shortcut key. Make sure you are writing the commands and their shortcut keys, as I am explaining to you. Polyline will be created in the same manner as line, and the thing that makes it different from a simple line is that a polyline is a continuous line and is connected with each other, unlike a line is created in separate segments. This can be understood by creating two squares of same dimensions, one with the command line and other with a polyline, like this. You can identify a line and a polyline on this simple visual. A line contains three squares, two at both ends and one at the mid. While a polyline contains two squares and one rectangle, squares at both ends and rectangle at the mid. I hope the command polyline is clear to all. Moving forward, the next command we have is M-line. A M-line is a multi-line. As the name suggests, it's not a single line, instead it is two parallel lines drawn together. Understanding M-line is a bit tricky and can be seen while creating a square of any value. I have used 200 as input. When we draw anything using the command M-line, there is a specific distance between both lines. This can be adjusted using the scale option under M-line. For this we need to provide command S after activating the multi-line command. So the command becomes ML, press enter, then type S and press enter. Now we are inside the scale option of multi-line. The default distance is set as 1, so we need to provide our required distance and press enter again in order to get it accepted. Now we can create a square of 200 with distance between line as 10 like this. As we have created a square using the command M-line, we can clearly see an issue with the square as the ends are not perfectly closed with each other. Now in order to make sure the square looks perfect, we need to use another command known as multi-line edit. This command only works on M-line. The shortcut for this command is ML edit. Once we enter this command, we get a dialog box in which we have multiple options. For now, we will only look at the option corner. We need to select this, and then we need to click on two lines one by one, hence the corner issue will be solved. This covers both of today's topics. I hope this topic is clear to all, and in case you are facing any doubt, kindly drop any questions or doubts in the comment section. The next topic will be covering spline and X lines. After that, we will move on to the modification commands. Kindly subscribe to our channel in order to receive the latest updated videos, and do press the bell icon to receive all notifications. Welcome to today's tutorial. Today we will look at the function keys. That is, we will learn what the keys from F1 to F12 are meant for. So, let's start in the increasing order. F1 is the short key for help if you are stuck on any command in Autocad and just want to get a vision on how it is used. Kindly press the F1 key to open help document. Here you can find the theory about how to use that command. Moving on to F2, it is expanded history. This displays an expanded command history in the command window. Next is F3, it is used for object snap. Object snaps are the markings provided by the software in order to help us identify the endpoints, midpoints, intersections, tangents, and others, which makes it easy to work in Autocad. Then we have F4, it is a 3D object snap. This is the same as object snap, but in a 3D model. Next is F5, this is isoplane. Used in isometric drawings to switch between different isoplanes. Then comes F6, this is dynamic UCS, again used in 3D modeling. To take software assistance in drawing on different planes. Next is F7, grid display. This simply turns on and off the display grid we have at the starting of any Autocad file. Then we have F8, that is ortho mode. It is used to make straight lines. By making ortho on, we force the line or polyline to move only in the horizontal and vertical direction. Next comes F9, grid snap. Used to trace the grid snap points and draw according to the grid snaps. We don't generally use this as it restricts the freedom of drawing. Then is F10, which is polar tracking. It is used to trace down different angles as per our requirement, as it would be difficult and time-taking to do that without taking the help of the software. Now it's F11, it's object snap tracking. It helps to place a magnetic track to identify the same length between two lines. This tracks the cursor horizontally and vertically from object snap locations. The last one is F12, this is dynamic input. This displays distances and angles near the cursor and accepts input as you use tab between fields. I hope all these short keys are clear to you. We will look into them deeply as we proceed with our tutorials and use them. Do watch our next video as we move a step ahead with our tutorials. This covers both of today's topics. I hope this topic is clear to all, and in case you are facing any doubt, kindly drop any questions or doubts in the comment section. Welcome to today's tutorial. Here is how to draw a circle in Autocad. But starting here, I will assume you can easily draw a line. Let's first look at where the circle command is located and how to activate it. The icon to activate this command is located on the upper left corner of your main window. To activate the circle command, simply click on the circle icon. The command for the circle is C. In Autocad, the most obvious and straightforward method is to click on the circle icon. Then you need to specify the center of the circle with a click in the drawing area and then enter the radius value of the circle. Sometimes the information you have about the circle you want to draw is neither the center of it nor its radius. This is where comes other option of the circle command. The other option you can use is the center diameter. If you are using this option to draw a circle, you will simply need to repeat what we did earlier, with the only difference that you will have to enter the value of the diameter of the circle instead of its radius. The next option you can use is 2 points. This option helps you draw a circle using 2 endpoints, where the 2 points will belong to the perimeter of the circle. To use this, we need to activate the circle command and then specify the first point. And after that, we need to specify the second point. The other option you can use is 3 points. This works absolutely like the preceding one. The only difference is that instead of 2 points you have to indicate 3 points. The next option we have is tan radius. In this, we need to provide two tangents and a radius value to draw the circle. The last option in the circle is tan tan tan. The tan 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 uses three tangents to draw the circle. We have just covered all the methods you can use when you want to create a circle in Autocad. Some of these methods might not make sense to you at the moment, but it is always good to know what the possibilities are, just in case they might come in handy sometime in the future. I hope this topic is clear to all, and in case you are facing any doubt, kindly drop any questions or doubts in the comments section. The next topic will be the modification commands. Kindly subscribe to our channel in order to receive the latest updated videos, and do press the bell icon to receive all notifications. Welcome to today's tutorial. Today we will look into some of the most useful modification commands, which are move, copy and rotate. Moving and copying are frequently needed actions when you work on a CAD project. It is time to learn some of the modification commands. These commands are used to modify the created or already existing sketches or drawings. Now let us learn how to move and copy objects in Autocad. Two simple commands, yet very important. Let's see how to move an object in Autocad. The move command will help change the location of an object in the drawing area. To use the move command, select the object or objects to move. Then you need to click on the icon shown on the move icon, or you can provide the move command that is M. After that, select the base point with a click, and remember that you don't hold. Then simply move and drop. Notice that when moving an object, you can activate the ortho mode and use the command area to enter the exact distance you want to move the object with. The ortho mode will ensure you are moving in a straight line. We have discussed the ortho mode in the previous tutorial. Do check the tutorials if you have any doubt. Let us take an example to understand the move command. Let's move the 6 circles below to the right. Step 1 is to activate the ortho mode to constrain the cursor movement orthogonally. Step 2 will be selecting circles. Step 3 is to click on the move icon or input command. Step 4 is to select the base point about which you want to move the object. And the final step 5 will be to move your cursor to the right, leave the mouse in that position, then enter 55 and hit enter. Now let us move on to how to copy an object in Autocad. The copy command works similarly to the move command, with the only difference that it leaves a copy of the original object in its position. Feel free to use the Ctrl+C and Ctrl+V to copy and paste objects in Autocad. To copy objects in Autocad, you need to select them first, and you can as well use the technique we used above to place the copy at a certain distance and angle from the original item. Now moving on to the rotate command. The rotate command will simply help rotate an object. You need to recall the Autocad tutorial where we learned how to draw lines and angles. It will be important to remember the idea of angle in Autocad and the trigonometric circle. Now for an example, we will rotate a square to 120 degrees. To rotate it, we need to select the square. After that, we need to click on the rotate icon or provide the command R. Then specify the base point. And lastly, specify the rotation angle, positive angle for anti-clockwise rotation and negative angle for clockwise rotation, and hit enter. This is the way we use move, copy and rotate commands. I hope this topic is clear to all, and in case you are facing any doubt, kindly drop any questions or doubts in the comments section. Kindly subscribe to our channel in order to receive the latest updated videos, and do press the bell icon to receive all notifications. Welcome to today's tutorial. Today we will learn a very important command, that is array. The array command in Autocad is the magical command you will find yourself requesting a lot while working on Autocad. This command helps create a pattern of objects ranged in the following manner: polar arrangement, rectangular arrangement, path arrangement. You can find all these commands under the Modify section of the ribbon panel. Let's explore the array type individually. The first one is polar array. The polar array is the most used of these, and the command corresponding to it is arapolar. If you type arapolar and hit enter, it will activate this command. This command will help you get the following done. Notice how nicely we copied the reference object and displaced copies around the circle. This is what the polar array will help you do. We got figure 2 and figure 3 from figure 1. Before the use of this command, you will need a reference object. It could be anything. To use the polar array command: 1. Click on its icon, shown above, or type Arapolar and hit enter. 2. Select the reference objects and hit enter. 3. Specify the center point of the array. You will then have access to the following tools, where the most interesting for now is the following. As you can see in the image of the polar array we created above, we have 6 elements. You can enter the number of items you need in the provided box shown on the image below. The maximum fill angle is 360. You can decide to rotate items on the circle or not to rotate them. Figure 2 shows rotated items, and Figure 3 shows item not rotated. The direction features help you rotate items clockwise or counterclockwise. This makes more sense when the fill angle is less than 360 degrees. The associative feature unites all items in one block. The following image shows a polar array with 6 items, fill on 180 degrees. The next type is path array. The path array corresponds to the command line array path. It works just like the polar array, but will distribute objects along a path like on the image below. And now we have rectangular array. Last but not the least, the rectangular array will help place objects in rows and columns as shown below. These commands are important and need to be mastered. You will have to play with their respective features to see how high or low their potential are. Feel free to comment your question in the comments section, they will be answered at the earliest. Welcome to today's tutorial. Today we will look into the command layers. Layers are the primary method for organizing the objects in a drawing by function or purpose. Layers can reduce the visual complexity of a drawing and improve display performance by hiding information that you don't need to see at the moment. Because you draw objects on separate layers, it is easier for you to understand the drawing. You can quickly know an object type by checking the layer. Autocad drawings are just lines and arcs. Let's see how working with layers helps while using Autocad. Layers are independent drawing spaces that stack on top of each other to create an overall image. Organizing objects in layers is important when you work on big projects, architecture for example. You use layers to organize your project in such a way that every group of similar things is in their own layers. In the following image, I have created 3 layers. I have given each one a unique color for you to differentiate between one and the other. Now let us focus on how do layers help. Let's look into simple steps of creating layers in Autocad. To create a layer, click on the layer properties icon. The following will pop up and then click on the indicated icon to create a new layer. The following shows the layers I created for the exercise above. Each of your layers can be customized, such as having its own line type, line weight, transparency and plot style. Now, close the windows when you are done creating layers. Let us learn how to manipulate different layers. To put an object in a layer, make sure when you are creating that object, its layer is set to current. Let's understand this with an example. If we want to draw a circle in the layer named Small Circles, I will make sure I select it first before drawing. If you created an object in the wrong layer, don't worry, it is possible to put an already created element in a different layer. Simply select the object, select the layers you want that object in, and press ESC on your keyboard. There is a very useful command match properties, and the short key is MA. It allows us to copy all layer properties. Let us now understand the Layer Properties Manager. You can add, delete, and rename layers, change their properties, set property overrides in layout viewports, and add layer descriptions. The various options we get in this tab are New Layer. This creates a layer with a default name that you can immediately change. The new layer inherits the properties of the currently selected layer in the layer list. Then we have as New Layer Frozen VP in all viewports. It creates a layer and freezes it in all existing layout viewports. This button is accessible from the Model tab or Layout tabs. Next we have is Delete Layer. This deletes selected layers. Some layers cannot be deleted such as layers 0 and F points. The current layer. Layers used in a block definition. Layers used in an external reference. Layers in a partially open drawing. This is not applicable to AutoCAD LT. Please be careful about deleting layers if you are working on a drawing in a shared project or one based on a set of layer standards. Then we have the option as Set Current. It sets the selected layer as the current layer. New objects are automatically created on the current layer. We have three options: On, Freeze, and Lock. Let us look at the option On. This turns the selected layers on and off. When a layer is on, it is visible and available for plotting. When a layer is off, it is invisible and not plotted, even if the setting in the plot column is turned on. Then we have Freeze. This freezes the selected layers. You can freeze layers to improve performance and reduce regeneration time in complex drawings. Objects on frozen layers are not displayed, plotted, or regenerated. In drawings that support 3D modeling, frozen layers are not rendered. Not applicable to AutoCAD LT. The last option is Lock. This locks and unlocks the selected layers. Objects on a locked layer cannot be modified. These commands are important and need to be mastered. You will have to play with their respective features to see how high or low their potential are. Feel free to comment your question in the comments section. They will be answered at the earliest. Hello and welcome to today's tutorial. Today we will learn about ellipse, fillet, trim and extend. For ellipse we can choose from the top icon or we can provide the command press enter, then press C enter. Then we need to click the center point of ellipse and then provide radius value for both axes. Now to make fillet. Fillet removes the sharp end between two lines. The curved part between them is known as fillet. For example, we will create a fillet of radius 30 between these two lines. Now the logic says, if I put the radius value as 0 then the unjoined lines will be joined. We can use one more shortcut, that is without defining the radius value. Press F then keep shift pressed and select two lines. This will force selected two lines to meet in the best possibility. Let it be parallel lines, they will be joined with the form of arc. Now looking at the trim, we use TR command and click the part which you want to trim. And same way we can extend the line by using EX. If we want to convert lines into polylines, we need to select them and provide join command, that is J. Select all lines and use type J, then press enter. And if you want to convert the polylines into lines, we need to select them and press X, then press enter. This way we can convert lines into polyline and vice versa. Now let us look at the command polygon. Anything with 3 or more sides is a polygon. For creating a polygon we need command POL. After this, we need to specify how many sides we want for X6. Then we need to click the center point and then we need to specify either inscribed or circumscribed. Inscribed means the polygon will be created inside the radius value we will input. And circumscribed means the polygon will be on the circumference of the radius value we will provide. See the following example. Then we have the polygon with the edge method. Provide command POL and then specify the number of sides and then click edge option. Then provide the starting point and specify the edge value. Here in the following example we will create multiple polygons of edge length 40 and number of sides starting from 3 to 10. Hope you are clear with the multiple commands covered in this tutorial, and if you are facing any doubt then drop your query in the comment section. Welcome to today's tutorial. Today we will learn about isometric drawings. An isometric drawing is a type of 3D drawing that is set out using 30-degree angles. But starting here, I will assume you can easily draw a line, polyline and use commands trim, extend, move and copy. Before starting with the drawing we need to make sure we change the snap of our file to isometric. Autocad have a separate snap for isometric drawings, which makes it easy for us to draw, and it forces the lines to move at 30 degrees. Hence producing a precise drawing. To change the snap enter the command DS, which is drafting settings. Then go to the first tab, that is snap and grid. Under this tab change the snap type from rectangular to isometric. By doing so we can see the change in our grids as the spacings of X grids change from 10 to 17. Which means a square will look like a rectangular and a circle looks like an ellipse when seen at 30 degrees. Now another change can be seen in the cursor as it turns green and red. This means that our line can now only move in the green axis direction and in the red axis direction. Make sure to keep ortho mode on as it forces the lines to maintain 30-degree constraints. Use F7 key to turn on and off the grid display. Now here we understand the importance of isometric drawing. If we only have the top, front and right view of any drawing, it becomes difficult to visualize the 3D look of that object. But when we have an isometric drawing supporting all three views, then a person get a clear vision of how the object will look like in 3D. Now as soon as we change the settings our cursor will be changed. Remember that now our line can only travel in the direction of red and green lines. Provided our F8 ortho mode should be on. Now looking at the diagram we can see three faces. Top isometric plane, left isometric plane and right isometric plane. Use F5 to switch between planes. Now our line will only travel at 30 degrees. Again, our line can only travel in the direction of red and green lines. Provided our F8 ortho mode should be on. We cannot turn F8 off. Now let us understand with example. We need to work with F5 and switch angles and use copy command to create similar things. Now we can create any face first and then proceed with the diagram. This was the top. Now right isoplane. And third we create left isoplane. Now we can copy the faces like this. Follow these steps. We will only use move, copy, trim, extend. Remember rotate, array, mirror will give wrong results. Copy this at a distance then connect all the edges. Now remember the proper look will come when we delete the edges which will not be visible. Let us now draw circle in isometric. If we create circles using the normal circle, they will look like this which are not correct. That is called iso circle, and the command will be L press enter, and I then again press enter. Change the face of the circle by using F5. This way we can create isometric keeping in mind the object in real and remember which lines or edges will be visible or not. If you face any doubt kindly use the comment section below. I will reply as soon as possible. Let us today learn how to create a rectangle in Autocad. This command creates a rectangular polyline. Creates a closed rectangular polyline from the specified parameters such as its diagonal corner points, dimensions, area, and type of corners. First, select the rectangle tool from the top and then click. The click specifies a corner point of the rectangle. Then we need to specify the other corner point. This will help in creating a rectangle using the specified points as diagonally opposite corners. We have three options by which we can create a rectangle. The first one is by area. After specifying the first corner point, we need to select the area option in the command line. This creates a rectangle using the area and either a length or a width. The second option we have is by using dimensions. For this, instead of area, we need to select dimensions. Then we first need to define the length, and then we need to define the width. Creates a rectangle using length and width values. The last option we have is rotation. This creates a rectangle at a specified rotation angle. For this, we need to select the rotation option instead of area and dimension. Then we need to provide the rotation angle at which we need the rectangle to be made. Then we have some other options also, such as chamfer, elevation, fillet, thickness, and width. At first, we will look at the chamfer option. This sets the chamfer distances for the rectangle. Follow the steps to apply chamfer onto a rectangle. This value becomes the default for the active drawing until you enter a different value. Next, we have is elevation. This specifies the Z value for the rectangle. The default is 0.0. And by providing any elevation value, the rectangle is created at that specified height. This value becomes the default for the active drawing until you enter a different value. The fillet is the same as a chamfer, but it is a curve and used to remove sharp edges of the rectangle. Specifies the fillet radius of the rectangle. Then we have the thickness option. This is also visible in the Z-axis, and it specifies the distance that the sides of the rectangle appear to be extruded. The default is 0. Note: this value becomes the default for the active drawing until you enter a different value. The last one is the width. This will be visible in 2D, and it is the width of a complete rectangle from all sides. Specifies the polyline width of the rectangle to be drawn. Hope the topic is clear to all, and if you face any doubt, kindly use the comment section. I will answer as soon as possible. Kindly subscribe to our channel and follow the complete tutorial videos. Welcome to Cadd Excellence Centre. Today we will learn about how to practice AutoCAD. For this, we have taken these basic diagrams for improving our understanding of AutoCAD. We will start with the basic line command. We will start from the bottom left corner of the I section. Just click the first point, then move the cursor towards the right and give the value. Step by step. And bend by bend, just move the cursor to the direction the line is going and keep on providing the length value for the direction. This method is the direct method in which we just provide the direction and value directly. This way we easily complete our I section. Now moving on to other sections following the same method. Taking this green line reference helps in keeping the sketches in line. Enjoy the music while you practice. Enjoy the music while you practice. Enjoy the music while you practice. This way we complete our FHE and T sections. Do not forget to take the green line reference to maintain uniformity. Now this last sketch we need to draw the lines through the midpoints which are indicated by the help of green triangles. Hope this session was easy to understand and repeat this 2 to 3 times to get a hold on this software. Try to make the sketches faster and faster in each new attempt. Subscribe to our channel for more such videos on Autocad and other CAD software. Ask your doubts in the comment section. JFDS, HJN. Hello and welcome to Cadd Excellence Centre. Today we will learn about how to use array command in Autocad. Array is the command used to create multiple instances. If you want to create multiple copies of any object in some particular manner. The three types of array we have are rectangular array, path array, and polar array. Let us look at rectangular array. It is used to create a pattern of rows and column. For this we can select the option from the ribbon tab. Or we can provide the command that is AR below. Once we select the object on which we need to apply array, we need to select the rectangular array option from top. As soon as we select the option, we will get an arrangement of 4 columns and 3 rows with predefined distances. This arrow helps to increase number of columns manually, and this one increase the number of rows. The distance between the rows can be roughly adjusted using this arrow. And same for the columns using this arrow. Pulling the square changes both rows and columns together. We can manually type the numbers we want in the tab above. The between distances can also be changed according to our preference. Keeping in mind to only change one thing, whether between distance or total distance, as between distance is dependent total distance. We can change the number of levels, but that takes our drawing to the Z-axis, which is not needed as we are in 2D drawing. Once everything is done, click the green tick mark on top right. Move into the path area. We can use this when we have an object to be applied array on a particular path. The path can be a spling, zigzag or a straight line. All we need to do is select the object, then select path array, and then click onto the path. Automatically after clicking the path, number of instances will be created on that path. We need to change the measure option to divide in order to be able to change the number of instances we want to create and fully utilize the path. By this option we can increase the number of rows, but this is not much needed. Then we have polar array. Remember, a path cannot be closed. That is, a circle is a path, but path array cannot be applied on the circle. We have polar array for objects that require circular pattern array. For this, all we need to do is select the object, select polar array, and provide the center point around which the instances will rotate. Now by default we get 6 instances, and if we want to change it, we can change everything from above tabs. Change the angle from 360 to 180. Change the direction on which side to create. Change whether the object should be rotated or not, and so on. Experiment with the tabs and understand the changes. Hope array is clear to all, and if you face any doubt, kindly use the comment section. Like, share and subscribe the channel and watch the complete AutoCAD series on our channel.